Okay, we're live with the Tuesday After School group. Everyone say hi. Okay, so we're going to start by talking about population density. I'm sorry, by Cavalier's principle. So you should be looking at the paper that says volume and Cavalier's principle. So I want to talk about some of these things. These are tri-filled papers. I've just pulled the questions out. I'll be going back and forth between this because I didn't have time to make all the videos how I wanted, but you'll get an idea enough. So here's the concept with this principle. If I have you as a student, and if you came to after school, these are the main words, God bless you, that you really need to know. You need to know the word parallel, cross section. It's in bold print, but pay attention to the words parallel, cross section, equal area. If you see parallel, cross section, equal area, you know the volumes are going to be the same. And so you are guaranteed to get at least one question on the DA regarding this information. So what that means is even though this base is kind of like a straight up and down prism, even though this one is tilted, and even though this one is a circle, because those B's, those capital B's, are all the same, that means that those cross sections have equal areas, even though the shapes look different. Same thing here. Here we have a triangle, but it says the area is 16. Here we have a square, but it says the area is 16. And here we have a bizarre looking polygon, but the area is 16. So because those areas are consistently the same, we know the volumes are the same, even though they look completely different. That's the whole premise of this principle. So moving on, let's look at a question. So now you're going to flip to the other side and let's take a look at this couple of these questions that relate specifically to this principle. Look for the one that says, these aren't necessarily in order. It says a circular garden has a diameter. Oh, is it not the other side? It's on the same. Okay. Excellent. So a circular garden has a diameter of 12 feet. So I'm just going to draw a circle, preferably in a pen that's actually readable. And I know it says 12 feet is the diameter. So I'm going to draw a line and put 12. It really will help you, especially for this test, that you draw as many pictures as you can. Just like the EOC, you're not going to be able to like write on the test. Like you couldn't write on the computer screen. Some of y'all did, but you couldn't. You can't write on this paper thing. But this breakdown of the 26 questions, 22 of them are DOK2. Of the EOC, over half of them were DOK1. What that means is they make these questions harder on purpose. So if you don't draw pictures, you will probably have a really hard time. Okay. So it says it's got a circle garden diameter of 12. How many bags of topsoil must Linda buy to cover the garden if one bag covers an area of 3 square feet? Now, this is not exactly Cavalier's, but we're having to look at two things. So if you go to your formula sheet, right here on the bottom of the formula sheet, which I know I did make copies of. I gave you like my leftover copies. The bottom left, it tells you the formula for area of a circle. The formula for area of a circle is pi r squared. But the catch is they gave us the diameter. So what's our radius for this circle? 6. So now we're going to get our area equals pi, and then we're going to put in 6 squared. So then we're going to put in, this will be 36 pi, and I forgot my calculator somewhere. Oh, no, here it is. And then when you do 36 times pi, what I would do is I would use 3.14. I wouldn't use the pi button. You're going to get the area equals 113.04. Now, here's the problem. It tells us that one bag covers 3 feet. Who's got an idea about how to do this now? We could multiply by 3, but that means that each one of those needs its own bag. So what this is saying is this entire thing is 113. That's a good guess. Who's got another guess? If this whole thing is 113, we divide by 3. Yep. So we're going to divide this by 3. And when we do that math, we get 37.68. So if they want to be sneaky with you, They might give you one answer is 37 and one answer is 38 just to see if you know how to round. So you just have to take your time. In this case, what would we round it to? 38. Yep, you wouldn't round up to the 40 because why would you round to the tens? So the answer would be you need 38 bags. The other thing is they might ask you 37 versus 38 because some kids don't realize if you still need 0.68, you need a whole other bag. So that's kind of where that comes in. Let's look at another one with Cavalier's principle. We have 2 stacks of 23 quarters. Each are shown below. One stack forms a cylinder, but the other stack is not. What is the principle why? Now, the good news for this is your test is multiple choice. So what were the 3 main things you had to use to explain Cavalier's principle? There's 3 things. Same height. What type of area? You're right. Begins with a C. It's a really long word. Cross-sectional area. And then what's the last thing? Begins with a P. Parallel. So you need to make sure that you see that it says that parallel planes have the same cross-section area. And that's how you would describe it. So basically, if you take out a quarter, no matter where you take out a quarter, it's still a quarter. So that's what it means by cross-section area. No matter where you take out the quarter, you still get about the matching cross-sections are the same. Okay, let's move on. You guys are doing fantastic. If you have questions, stop me. Yeah. We good?
No, hold on.
Gotcha.
Not talking, right?
I'm going to move on so we can keep going. Here's the next one. Let's look at this one. Using Cavalier's principle to decide which of the figures described below has the same value as, let's see the information they gave you. The cone base is a radius of 3 and a height of 12. So what are the 3 things again that we have to have? Height and the same cross-section area. CRS area. So right away we can eliminate B because B does not have the same height. So now we're stuck between A, C, and D. So what's the base of a cone? Who remembers what the base of a cone is? What shape? A circle. So we're going to figure out what the area of the circle is. So we know that we've got pi. It gives us the radius. We don't have to divide it in half. So when we do 9 pi, sugar shoots. I still got to learn the trick, Christian's trick on this calculator. We get 28.27. So now we're seeing which A, C, or D gives us a base of 28.27 or 9 pi. So let's look. A rectangular prism with a base area of... Okay, so right away we know, let's see, this is a cylinder with a base of 6. Well, remember a cone forms like a triangle, right? So we know a cylinder, if the base is 6, that means the whole way it's always going to be the same base up. So we're going to eliminate choice A because of the word cylinder. Because the formula for a cone is what? Who remembers? It's also on the formula sheet. 1/3.
1/3 pi radius squared times height.
Excellent. 1/3 pi radius squared times height. What's the volume of a pyramid?
I thought it was like 1/3 base times height.
Yep. 1/3 base times height. So look at what they have in common. This has 1/3. This has 1/3. This has height. This is height. So really, we're looking for which of these shapes has a base area of 9 pi. So our answer is going to be C. It's not going to be D because remember, a rectangle prism is going to have the same area all the way up. So we needed to match the 1/3 and the 1/3. Yep. So this one we had to think about the formulas of the shapes. So because the formula of a cone is 1/3, excuse me, we had to make sure that whatever formula we looked at also had 1/3 in it. So the formula for a cylinder is pi r squared height. There's no 1/3. So we can't even consider the cylinder. Then the formula for a rectangular prism is just base times height or length times width times height, which also doesn't have 1/3 in it. So that left us between B and C because both a cone has a 1/3 in it and the pyramid has a 1/3 in it. But we also had to look at the heights to make sure our heights were 12. And that's why we chose choice C. We good? Everyone signed in?
No.
All right, let's go to the next one. Okay, now these are just pictures you need to know. I'm telling you, according to the blueprint, one of these shapes is going to be on your test. Which shape it's going to be, I can't tell you, but one of the, because I don't know, but one of these shapes is going to be on your test. So let's take a look at it. For a cylinder, remember a cylinder, we have circles going up and down. So if we cut a cylinder in half across, we're going to get a circle. If we cut a cylinder, they'll say like on the oblique cut, but like diagonally, you get an oval. And if you cut a cylinder straight up and down, you get a rectangle. You just have to know these. I know it stinks, but it's how it is. Your teacher might have used Play-Doh when he or she taught you. Yeah. Okay, for the cone.
You gotta know what like
Yep, because it'll say something like, which shape has a cross section that's in the shape of a rectangle? And you'll have to think about all the shapes and be like, well, it's not going to be a cone because there's no way you can get a cone. But a cylinder can have a cross section that's a rectangle. Or they might say something like in the first one, they might say like which of the following shapes is not a cross section of a cylinder. And they might give you circle, oval, rectangle, triangle, and you'll have to know triangle is not a cross section. So it's stuff like that. On one of the review sheets that your teachers might have given you, I think there was a question about a cube, and we'll look at the cube picture coming up. So here, a cone can have a circle, a cone can have an oval, and a cone can have a triangle. Next one. Yep. It's also on the paper. It's on the paper I gave you. That's fun. Next, here, let's look at a pyramid. So for the pyramid, you can cut the pyramid straight down. Sugar shoots. Okay, you can cut the pyramid straight down. That gives you a triangle this way. You can cut a pyramid at an angle. So it's like part on this side and part on the bottom. That gives you a trapezoid. Or you can cut a pyramid straight across, and assuming it's a square-based pyramid, you can get a square or a rectangle. The main thing that you think about is you just visualize it and picture cutting it. It's a visual spatial one. Spheres, you're going to get, thank you. Spheres, you're going to get circles the whole time. Okay. Yep, that's circle. Next. This next one is really the one, oh, I didn't put it on. We definitely got to look at it. Let's look at I thought I did. Here it is. This is the one that's so amazing. Look at the cube. So a cube, I didn't know this, but a cube, I knew you could get a rectangle by going diagonally. Because remember, think about like a squared plus b squared equals c squared. The hypotenuse is always going to be longer because of the right angle. You can get a triangle by cutting off the corner. You can get a trapezoid by cutting off at an angle, the top and bottom. And who knew this, Jaymani? You could actually get a hexagon if you connect the midpoints of 6 of the sides. So the hexagon is the biggest shape that you can get inside of a cube. I think the question on one of your review sheets said something like, can you get an octagon in a cube? And the answer is no. The hexagon is the biggest shape that you can get on a cube. Okay, next. So let's look at a couple questions. So here it says the volume, a two-dimensional cross-section, is taken from a three-dimensional object. If the cross-section is a triangle, which cannot be the three-dimensional. So you have to say, okay, can I get a triangle from a cone? Yes, you can get a triangle from a cone going straight up and down, so it's not number one. It's a cylinder. You cannot get a triangle from a cylinder with one cut. If you notice here, you can only get a circle, an oval, or a rectangle. You can get it in a pyramid by going straight up and down, like right here. And you can get it in a rectangular prism, including a cube, by just cutting off the right angle. So that's why it's choice 2. Let's go to number 5 right here. The cross-section of a regular pyramid contains the altitude of the pyramid. All that means is it goes straight up and down. So if we have our pyramid here and we cut straight up and down to get a right angle, what can we get? Who's got an idea? Can you get a circle out of a pyramid?
No.
Can you get a square going straight up and down? No, you'd have to do parallel to get a square. So the square is parallel. So the answer is a triangle. Okay? Just like how it is right here in this yellow one that I'm coloring in. You get the triangle by going straight up and down. And the key word is altitude. Altitudes form right angles. That's the key word. Number 6. If the length of a side of a cube is 7x, which represents the cube's volume, this is actually testing you. It's actually testing your idea of multiplication. Because what happens is kids think of it like this, or they think of it like this, and they're just like, oh, that 7 stays there, and they only cube the x. But the whole side is 7x. So this is really saying 7x times 7x times 7x. Because if you have a cube, we know this side is 7x, this side is 7x, plus this side here. So you have to do 7 times 7 times 7, and then the x cubed. Do you need me to do that again? I feel like I did that fast. We're good? Okay. A fish tank with a rectangular base has a volume of 3,360. So it tells us a rectangular base, so we're going to do volume equals length times width times height, because we know the fish tank has got to be a rectangular prism. It tells us our volume is 3,360, and it gives us the measurements of 14 and 12. It wants us to find the height. This is literally an algebra problem, but with made to look like geometry. So all you're going to do is 14 times 12, which gives you 168. And then what do we do to isolate the variable? Excellent. We divide 3,360 divided by 168, and we're left with x equals 20. And technically, you would find the one that says x equals 20 inches. A company is creating an object from a wooden cube with an edge length of 8.5. A rectangular cone with a diameter of 8 and an altitude of 8 will be cut out of the cube. Which expression represents the volume of the remaining cube? Well, so first we're basically taking a cube and we're subtracting a cone. So we know a cube is length times width times height, which they already did, which stinks. 8.5, 8.5, 8.5, 8.5 cubed. So really they're not testing us on our knowledge of a cube. What they are doing is testing us on the formula for a cone. So on the formula sheet, what's the formula for a cone again? 1/3 pi radius squared times height. So right away we can eliminate choice 1 because it doesn't have 1/3 in it. And we can eliminate choice 2 because it doesn't have 1/3 in it. So now it tells us that the diameter is 8. Well, if the diameter is 8, what's the radius have to be? 4. So it's going to be choice 4. 1/3, yeah. Okay, so the trick is, did you notice that they gave you diameter and now you need the radius? That's what makes it a trick. Okay, the Great Pyramid of Giza, Giza, who knows? Who's the history people in here? Is it Giza? Was constructed, the Great Pyramid was constructed as a regular pyramid with a square base. It was built with an approximate volume of that huge number and a height of that huge number. What is the length of one side? Now here's the trick. See the word square? So we're still going to use the formula for period, which is 1/3 times base times height. Remember, the base is really length times width. Oh, you know, but I should say period again, right? So here we have 1/3, but we know it's a square. So because it's a square, both the length and the width have to be the same. So we're going to have this be x squared times the height, which is this. And then I'm just going to put number because I'm not going to rewrite that number on the screen. So now I'm going to type in my calculator 2,592,276. Now, first I have to get rid of this 1/3. So what some people do is they actually just take the 1,465 and divide it by 3. So this gives them 488.3 x squared equals the number. That way they don't have to think about the third anymore. So then I'm going to type in that ridiculous number again, 2,592,276. Divide everything by 488.3. This leaves me with x squared equals 5,308. How do you get rid of the squared? We square root it. Excellent. We don't divide it. We square root it. So we're going to take the square. Yes.
I just want to know where you get x squared from.
Yep. Because this says it's a square base, we know that for the pyramid, it's a square base. So that means the sides have to be the same. So this side has to be x and this side has to be x. And then we have the height.
Okay.
So if it said it was a rectangular base, then we need to have two different numbers.
So basically, you just multiply side times side. So if you just use x squared differently. Okay. So you found the area of the square, then you add it to the formula, right?
I'm working backwards to find the area of the square.
Okay.
So, yep, let me say that again. Okay, look, here's the formula for the pyramid. Right here's the formula for the pyramid. Then what I did is I knew the base has to be x times x because it's a square base. Because squares, all the sides of a square are the same. So because I don't know what it is, x times x is x squared. If it was 5, I do 5 times 5 is 25, but I don't know what x is.
Okay.
So then I multiplied 1/3 by 1,465. That gave me this. I divided both sides by this to isolate the variable, get x squared by itself. And then we heard that we have to take the square root to get the number, and the square root will give us 72.8. So my answer is going to be choice 1. So this one's really tricky. It's long. It's not hard. You start with the volume and you have to work back to get the side. It's different than when you have the side and you have to work forward to get the volume. Ma'am, we're going to be making better choices right now. All right, so let's move on. Let's look at, I already did these ones, right? Yep. Yeah. I just didn't. Okay. That one I did. Okay, let's do proportions. Go to proportions, please. Proportions and density. We're at 309. We're still okay. The main thing to do with proportions. Okay, find your paper, then we're going to move on because I'm still recording. I see that, Christian. I noticed it before. I noticed it before. I noticed it. Yeah, that's funny. So with proportions, the main thing to remember is proportions are fractions and you cross multiply. You're going to use proportions 3, 2, 1. You're going to use proportions when you deal with similarity, specifically when you're doing for density where it says how many people per square mile. You're going to put the people on the top, the miles on the bottom. If it says how many miles per hour, the miles go on the top, the hours go on the bottom. So anytime you see per, you know you're going to set up some kind of proportion. Then you cross multiply. Some of your teachers, I forgot which math teacher says something called the butterfly method. The actual method is called cross multiplication. And the real thing is called the product of the means equals the product of the extremes. But basically, all you need to do is cross multiply. So let's look here. here we have population density also. So it says on a 4 meter by 3 meter picnic blanket. So right away, we know we're going to do something with area. And because it said 4 meter by 3 meter, we're going to multiply. So now we know the area is 12 meters squared. Then it says I counted 45 ants. So what is the population density? When you do population density, you're always going to have things, I'm going to say that you can touch. I stole this from someone else, over space. So it's things that you can count, things that you can measure. So we have 45 ants at 3 p.m. and our blanket is 12 meters squared. So if we need to figure out the population at 3 p.m., all we're doing is 45 divided by 12, which means at 3 p.m., there was 3.75 ants per meter squared, per. So then at 5 p.m., it says, and now I don't know why you still have a blanket out that had 45 ants on it, but nonetheless, at 5 p.m., there were 85 ants. But the size of the picnic blanket didn't change. It's still 12. So then again, we're just going to do 85 divided by 12, and we get 7.08. Now from there, we can, and that's again, ants per meter. The main thing to think about, miles per hour. How much money per hour do you make? I make $8 per hour. I make $5 per hour. Density, those types of comparisons are important because I could have someone say, oh man, my paycheck was $1,000. Another person says my paycheck was $800. You're like, oh, the $1,000 person got better. But if you find out that the $1,000 person had to work 100 hours and only got paid $10, but the $800 person got to work 10 hours and got paid $80 an hour, I'd rather get an $800 paycheck for 10 hours of work than a $1,000 paycheck for, 100 hours of work. So that's where comparisons come into place. So now we can say there were more ants at 5 p.m., there were less ants at 3 p.m. Joey finds a treasure chest packed with metallic coins. The chest volume is 1.5. So again, that volume is most likely in the denominator. It says it's got a mass of this. And again, all you divide because we want to find out what's the density. Mass, which is what you can measure, which they did it in kilograms. Sorry, that's kg. Change colors. Or over volume, which in this case is meters squared. So all you do is divide 16,950 divided by 1.5, and that gives us this. He's gonna make a whole lot of money. Okay. Next page. Here's an example of a proportion you might see. Because these are the sugar shoots, because this and this are the same, this is actually the mid-segment theorem. Mid-segment means that if these two things are equal and this is the middle and this is the middle, then one of these, I tell my students, look for the hidden parallelogram. This right here is also the same thing here, which is also the same thing here. Yep, I heard you. I'll do it one more time. So what mid-segment theorem said is, if you combine the midpoints of a triangle, this side here is going to equal half of this side, or vice versa. So for example, if this side is 5, how long is the bottom? 10. That's it. If this part is 7, how long is this whole thing? 14. So here, how this side is 3x minus 30, we actually have to have 2 of those to equal one of the bottom. Just like if this was 5, we would do 5 plus 5 to get 10. So all I was showing you is you just have to double the small to get the big. So now we're going to do algebra. 3x plus 3x is 6x. 30 and 30 is 60. I'm going to move the 2x over because I'm lazy and I don't like dealing with negative numbers. Then how do I move the 60? add. And we probably won't hit probability today. We'll hit it on Thursday. So we get x equals 14. So I don't know, have a clue why I put it in here, because maybe I was thinking proportions. I don't know. But just again, when mid-segment, when those pieces are equal, one small equals two big. That's it. Same thing kind of when you think of like inscribed angles. We're going to do circles on Friday, or on sugar shoots Thursday. Remember how we do arc to angle, we divide by 2, angle to arc, we multiply by 2. It's the same idea. Small to big, multiply by 2, big to small, divide by 2. PD4, right here. An equipment manufacturer is planning to bring out a new line of exercise equipment. The company conducts a survey by randomly selecting 250 customers at the sporting goods store. Of the customers surveyed, 35 would purchase the new equipment. In a city of 50,000, how many customers would the manufacturer expect to buy? So what we're going to do is we're going to do buy over total. This is something you learned in elementary school, right? Part divided by whole. So 35 people out of 250 people bought it the first time. So this is how many people bought it. This is how many people there are. So now it told us, well, there's 50,000 total people in the place, in the whole city. We want to know how many people are going to buy, assuming all things are equal. So this is where we do our cross multiplication. The P just stands for people, the no big deal. We've got 250x. I'm not doing that math in my head, it hurts. 35 times 50,000. Whoo, that's a whole lot. 1,750,000. Divide that by 250, and you can expect to sell 7,000 pieces of equipment. So again, it's just looking really quick. Part over whole, part over whole, part over whole. Alania can build 8 computers in 13 hours. So that 8 is kind of like 8 computers per hour. So I've got 8 over 13. That's what Alania can do. Sage can build 10 computers in 16 hours. So again, all we're doing is converting decimals. I've got 8 divided by 13. That gives me 0.61. I've got 10 divided by 16. That gives me 0.625. Who's the faster person? Who's got the bigger number? Sage is the faster person. Yep. Sage is faster because his number is bigger, or her number. I don't know if Sage is a girl or boy. It's bigger. Okay. Okay, this is 0.61. Alana and Sage. Okay. Next. Actually, technically it's 0.62. The 3-digit number is 0.615 for Alana. Okay, number D. Guys, 2 more. You're confused? Where? Oh, sugar shoots. Okay, I'm going to say this real quick because I hear there's confusion. So here we have Alana, or Elena. Quiet. She builds 8 computers in 13 hours. So altogether, she builds, looking at my calculator, 0.615 computers an hour. That's how many she builds in 1 hour. So if she works 100 hours, you would multiply it by 100. Sage is 10 divided by 16. That gives you 0.625. So because it wants to know how many people, who's faster, whoever has the biggest number is the faster person because they build more. So Sage builds 100th computer more per hour. You can't, if you round it, the issue, even if you round it, this would be 0.62 and this would round to 0.63. So Sage is still more. Okay. All right. Thank you for being patient. Let's do last two and then we'll be done. A study reports that in 2010, the population of the United States was this big number, and this was the miles. What was the density? Shh. Excuse me. Density is always how they tell you people per mile, things that you can count over space. So I'm going to put this big number in. Guys. And then you just got to do it, the math. 308,745, 538. I mean, they're trying to show you real world use of geometry.
You're gonna type it in wrong.
All right, so then it says round to the nearest tenth. So it would be 87.4 people per mile. The population of Orchard Hill has 360 people. The length of each, okay, this is a good one to end on. It's tricky. The population of Orchard Hill is 360. The length of each block is the same. And the length of 20 blocks is 1 mile. So we know that 20 blocks equals 1 mile. So right away, I would kind of look at it that each block is 0.05 miles. And I got that because 1 divided by 20 is 0.5. Right? Did I just do this in my, no, I did it right. Just like there's 20 nickels in $1, each one block is 0.05. So then, yep. We good? So because it says there's 4 blocks by 3 blocks, I'm going to do 0.05 times 4 to get this side, and 0.05 times 3 to get this side. No, don't skip it. I mean, here's the another way that you could do it is right here. Once you knew 1 block was 0.05, what you could do instead is do, well, 4 times 3 is how many? 12. And then just do 12 times 0.05. And that gives you 0.6. That's it. So, yeah, because there's 1 mile. For every 1 mile, there's 20 blocks. So that's why I did 1 divided by 20. Because in every 1 mile, there's 20 blocks. Think about it, like in every $100, there's $25 bills. Y'all know when you count your 20s from the ATM? Okay, so what I'm saying is that it says there's 20 blocks in 1 mile, so I took the mile divided by 20. Yes, sir. Yeah, so because it said there's 20 blocks in 1 mile, I wanted to know how many miles is in 1 block. So that's why I did the 1 divided by 20. 3, 2, 1, last question, we're almost done. Then it says, what's the population it says, given, what is the population density given as the number, quiet, as people per square mile? All you do is just divide. 360 divided by the 0, that, and then I'm not doing that in my head either. 600. 600 people per mile. Okay, don't start getting excited.
What was that? What's that number? 87.47.
You got this, Michaela.
Where?
Oh, okay, never mind.
Okay, so real quick, give me a second. Hold on.